So, you've probably made an API call to an LLM before. It's pretty cool, right? But what happens when you need to build a real production-ready AI application? Suddenly, it gets complicated. You've got to handle context, connect to tools, and you definitely don't want to get locked into a single provider. That's exactly where LangChain comes in. In this explainer, we're going to dive deep into how LangChain helps you build truly sophisticated agentic AI, apps that can actually think, remember, and take action. Here's a quick look at what we're going to cover. First, we'll talk about the why, all the real-world headaches you run into when building AI apps. Then we'll get into the what, this whole new paradigm of AI agents. After that, it's all about the how. We'll crack open the LangChain toolkit, see how to chain things together with LCEL, and finally put it all together to build a chatbot that actually knows what it's talking about. Okay, let's start with a scenario I'm sure a lot of you have faced. Your boss comes to you and says, "We need an AI chatbot." Sounds simple enough on the surface, but as any developer knows, the reality is way, way more complex. Your first thought might be, okay, I'll just grab an SDK, make a quick call to a model like GPT-4, and we're done. But you hit a wall almost immediately. How does the bot remember the last thing the user said? How do you get it to access your company's internal documents? This is where the simple idea of a chatbot starts to turn into a real engineering puzzle. All of a sudden, you're not just making a single API call. You're building a whole system. You need a way to handle memory. You have to figure out retrieval augmented generation, or RAG, to make the bot aware of your company's private data. And then there's the big one, vendor lock-in. What happens if you built everything for OpenAI's API and then want to switch to Anthropic? Your simple script just ballooned into this complex, brittle piece of software. To really solve these problems, we need to think bigger. And that's the fundamental shift that a framework like LangChain makes possible. We're moving away from thinking of an LLM as just a passive brain and toward building an active, autonomous AI agent. So what's really the difference here? Well, a standard LLM is like a brilliant brain in a jar. It's an incredible reasoning engine, but it's totally stateless and passive. An AI agent, on the other hand, is like putting that brain in a robot. It's a complete system that can reason, plan, and then execute tasks. It has memory, it has access to tools, and it can actually decide for itself how to get a job done. It's a dynamic actor, not just a static brain. An agent basically operates in a continuous reasoning loop. For example, say you ask it, "What was our revenue last quarter?" The agent first uses an LLM just to understand what you're asking. Then it might decide, okay, I need to use a tool to query our internal database. It goes and gets the data, synthesizes it into a nice human-readable answer, and it does all this while remembering the context of your conversation. And this is exactly where LangChain comes into play. It's not a model itself. Think of it as the ultimate workshop, the practical toolkit that gives you all the pre-built, ready-to-go components you need to assemble these powerful agents. At its core, LangChain is an abstraction layer. It provides the essential building blocks for agentic AI. It gives you standardized pieces for memory, for connecting to data, for using tools, so you don't have to reinvent the wheel for every single project. You know what's really smart about LangChain is how it organizes the solution into these logical modules. You get this unified interface for any LLM, which is the key to dodging vendor lock-in. You get prompt templates for consistent, reusable prompts. You get battle-tested memory systems. And, of course, you get the whole shebang for RAG, from document loaders to vector stores and embedding models. And this right here perfectly illustrates one of LangChain's biggest selling points, vendor independence. Look at this. Without it, switching models means rewriting a chunk of your code. With LangChain's abstraction, switching from OpenAI to Anthropic is literally a one-line change. This is a huge deal. It makes your application incredibly flexible and future-proof. Okay, so we've got all these awesome, powerful components, but how do we actually connect them? How do we make them work together? That is where the LangChain Expression Language, or LCL, comes in. It's the grammar, the syntax that lets you compose all these pieces into powerful pipelines. LCL gives you a declarative way to build your chains. What that means is you just define what you want the pipeline to do, not every little step of how to do it. You simply use the pipe operator, that vertical bar symbol, to chain your components together. The result is a workflow that's super readable and easy to manage. This simple syntax is way more powerful than it looks. A prompt template gets piped into a model, and the model's raw output gets piped into an output parser. See how that works? Each piece is a runnable, and that little pipe operator just composes them into a brand new, bigger runnable. It's a really clean, functional approach that's also super extensible. So here's what a basic pipeline looks like in practice. The prompt template doesn't just pass along the user's query, it also injects the relevant context that we retrieved. Then the LLM uses all of that to generate a smart response. And finally, the output parser makes sure that the answer is in the exact format you need, whether that's a simple string, a JSON object, or even a pedantic model. And I've got to stress, LCL is absolutely built for production. It's streaming first, which is critical for a good user experience. No more waiting forever. It's async native, so you can handle tons of concurrent requests. It supports batch processing for super efficient inference. And it's type safe, which, trust me, will save you from so many headaches at runtime. Okay, now for the fun part. Let's put everything we've talked about together and actually build our knowledgeable chatbots. The whole goal here is to answer questions based on our own private documents. And the key to making that happen is retrieval augmented generation, RAG. And what's great is that LangChain gives you components for every single step of this RAG pipeline. You use document loaders to pull in your data, text splitters to chunk it up, and embedding models to turn it all into vectors. Then you store those vectors in a vector store, something like Chroma or Pinecone, which you can then query with a retriever. The documents you get back are passed to the LLM, which generates a beautifully context-aware response. And really, this is the ultimate payoff. LangChain isn't just a random box of tools, it's a truly coherent framework. It brings together LCEL for composition, RAG for knowledge, and memory for context. It saves you from having to build your own custom semantic search, your own state management, and your own model switching logic, all from scratch. LangChain basically abstracts away all the tedious boilerplate, letting you focus on what really matters, the unique logic of your application. It turns what used to be a massive engineering challenge into a much more manageable, component-based assembly process. So really, the question isn't if you can build a powerful AI agent anymore, but what kind of agent are you going to build first?